So what I want to do here was explain exactly what's going on when we're trying to determine which of these compounds is more active. Now when I say more active also means a better oxidizing agent or a better oxidizer. So those two statements are equivalent. If I'm saying that one compound is more active than another, then I'm saying it's a better oxidizing agent than another. And we can talk about oxidizing power as well as activity there. All of those things sort of mean the same thing. But let's talk about what we're actually doing in this process when we're trying to figure out if between two elements, X and Y, which one is going to be more active. So the process involves taking a test tube, and the first thing we would do is put X2 into that test tube. Now X2 here is going to be green, so I'll just write X2 here for a start, then let's pick a different color here. We'll do green. That's what it's going to look like initially. So these are fictitious compounds, X and Y, that I'm talking about here, but it's just used for illustration. All right, so we've got that. Then what we do is I'll change it back to black now. The next thing we do is we add hexane. And the hexane will go on the top here, so this will be the aqueous layer down here. This will be the organic layer, or the hexane layer on top. And what will happen is that green then will come into the top layer. The next thing we would do then is add the Y, but we add it as Y minus because we want to see if there's going to be a reaction or not. If there's a reaction, then what's going to happen is that we can say that then the X is going to be more active than the Y. But if there's no reaction, then the reverse is true. The Y is actually going to be more active than the X. But it has to be the Y minus that we add. Now the Y minus is going to go into the bottom layer because it's going to be an aqueous solution as well. It's not going to actually go into the hexane layer as Y minus. So what we'd be looking for here is if there's a reaction, I want you to see what happens. If there's a reaction, look at what happens. The Y minus will actually turn into Y2, and if you look at what's going to go on there is that the Y2 would be red, and what would happen then, and this is after reaction, and this is really important to realize, is that the green here, which is going to be the X2 actually turned into X minus, and if you look up here, X minus is actually colorless. So what happens here is this green business will go down here into the bottom layer and become colorless, but the Y minus, which is colorless initially, will actually go up into the top layer, and that top layer will turn red. And that will indicate that a reaction has actually occurred. So as I said here, so I changed the color there. So what's going to happen here is that X2 would actually turn into X minus. So that was X2 up the top there, and now it turns into X minus, which is colorless, and it's going to be on the bottom layer. So we know that a reaction then has occurred. Now if there was no reaction, once we added the Y minus, then what we would see is no change. And that's really the important point to note here. So if you don't see that color change, you can assume that no reaction has occurred. So again, just summarizing, if we see that change in color, what's happening here is that the X is more active than the Y. And if it turns out that there is no reaction, then the Y must be more active than the X. And the reason is because the reverse process would be the one that would actually be the one that would be causing the color change in that instance. But that's really all you need to know.